Hey there everyone, welcome back to the concluding passage for test number 3, information theory and the big idea, or comma, the big idea. So what do we have here? Some sort of information theory. We have some matching features. Pretty much we're getting a lot of matching features, although I believe that from all the way from passage 1 to passage 3 we've been getting matching features here, and followed by some sort of sentence completion, and finally we have 3 true false not given. You have to remember that it's really essential. I mean, it's really quite comes in handy when you do understand the types of questions and how to deal it. You have your own specific technique to deal with each sort of question. So you have a matching features, and here we know that the questions, they don't follow the order. Whereas the Voyager space, we can see that it's some sort of sentence completion. They might sometimes follow the same order, but sometimes they might not. However, the thing is that, as we can see, it's a bullet point, and some bullet points are, that means each bullet point is sometimes refers to every single paragraph, meaning, for example, number 33 and 34, you might encounter finding the answers and all the way from paragraph A, whereas 35 you might even though find the answers in paragraph C, but that happens quite rarely. However, finally, true false not given, they follow the same order. They might probably come from paragraph E to F, or maybe even D. So we'll just begin and we'll see what happens. So first of all, I have two types of techniques, so even though maybe so to say strategy. I love to I can first of all read and then come back to questions, or maybe just read the questions first of all and then start reading it. So for this video purposes, we're going to deal one by one. All right, so let's get started here. An explanation of the factors affecting the transmission of information. Explanation of the factors. Factors, we know it's a reason. Explanation of the reasons affecting. So we need an explanation, some sort of an explanation of the. Okay, so let's choose once again green. Example of how unnecessary information can be omitted, meaning ignored. An example. A reference to Shannon's attitude to fame. Shannon's attitude to fame. That's what we want to highlight here. Now, question 28, you want to know that an example of how unnecessary information can be omitted. The word example doesn't necessarily mean that they're going to infer some sort of example. They're not exactly going to say, for example, or for instance, or any other expressions that that shows or some sort of a signpost that say that you may find as an example. So details of a machine capable of interpreting incomplete information. So details of a machine. We want to know that as well. Now, I want you to pay attention to the way how I'm highlighting it. It doesn't always. Once again, I don't necessarily recommend or advise someone to follow my own techniques. Everyone has to have their own. But however, what I'm trying to show you here is that when you're actually analyzing the questions, it doesn't. Many people just literally highlight all, or maybe even though the unnecessary part of a particular sentence. So you just want to highlight something you will encounter in the following passages or the text or paragraphs. A detailed account of an incident involving information theory. A detailed account, meaning a detailed information. All right, so you want to highlight that. Okay, a reference to what Shannon initially intended to achieve in his research. A reference meaning they're going to talk about Shannon's first intention. All right, so first of all, we're going to deal with this, and then we'll come back with that. All right, so what do we have here? So we have first paragraph. We have a lot of. All right, let's just begin with the first one. Information theory relies at the heart of everything, from DVD players and the genetic code of DNA to the physics of the universe at its most fundamental. that it has been central to the development of the science of communication, which enables data to be sent electronically and had therefore had a major impact on our lives. So paragraph A, in April 2002, an event took place which demonstrated one of the many applications of information theory. The same probe, Voyager 1, launched in 1977. So I want to see the Voyager 1 space probe. I want to know about this one as well. Voyager 1, launched in 1977, had sent back spectacular images of Jupiter and Saturn, and then soared out of the solar system in one-way mission to the stars. After 25 years of exposure to the freezing temperatures of deep space, the probe was beginning to show its age. Sensors and circuits were on the brink of failing, and NASA experts, I want to highlight these kinds of nouns or names, realized that they had to do something or lose contact with the probe forever. The solution was some sort of a solution. Let me actually choose green. So was to get a message to Voyager 1 to instruct it to use spares to change the failing parts. So to use the spares means that something extra that they have. With the probe 12 billion kilometers from Earth, this was not an easy task. By means of a radio dish belonging to NASA's Deep Space Network, the message was sent out into a depth of space. Even traveling at the speed of light, it took over 11 hours to reach its target, far beyond the orbit of Pluto. Yet, incredibly, the little probe managed to hear the faint call from its home planet and successfully made the switchover. So an event took place which demonstrated. So they're showing some sort of a process of what? Process of sharing or some sort of communication, and yet incredibly the little probe managed to hear the faint call. Faint call means not clear. Fainting means faint means not clear. Faint call means so you have a very unclear voice or unclear sounds of a call from its home planet, and successfully made it to switch over. So for this reason, an explanation of the factors, I would say number 31, a detailed account of an incident involving information theory, because in April 2002, an event took place which demonstrated an event. First of all, I want you to pay attention to the word incident. So let me actually, instead of highlighting them, I'm just going to underline them. There we go. An incident is an event, so involving information theory. So which demonstrated one of the many applications of information theory. So applications of information theory. So once again, if you just literally pay attention to the first paragraph, most of the times they talk about the main idea in the very first paragraph, or usually at the very middle between the details or explanations. However, you have to know that matching features are not like matching headings. They're looking for a specific information rather than main idea. So therefore, a detailed account. Incident involving means involving one of the applications of information theory, and incident is a synonym for an event. So I want to take that as well and underline that. And so yeah, so number 31 we have as A. I'm just going to choose this. Now B, it was the longest distance repair job in history and a triumph for the NASA engineers, but it also highlighted the astonishing power of the techniques developed. But we have a lot of contradictions. IELTS test writers, they just really love adding a lot of contradicting signs. But it also highlighted the astonishing power of the techniques developed by American communications engineer Cloudy Shannon, who had died just a year earlier. Born in 1916 in Petoskey, Michigan, Shannon showed an early talent for maths and for building gadgets, and had breakthroughs, meaning discoveries, in the foundations of computer technology when still a student. While at Bell Laboratories, Shannon developed information theory, but shunned the resulting acclaim. A very nice one. So the word shunned means shunning means to avoid something. So to avoid a public approval. So shunned a resulting acclaim is like avoided or ignored public approval, with praise. They wanted to praise him. And in the 1940s, he single-handedly created an entire science of communication, which has since inveigled its way into a host of applications, from DVDs to satellite communications to barcodes and any area, in short, where data has been conveyed rapidly yet accurately. This is a really good one. And the word, while at laboratory, Shannon developed information theory but shunned the resulting acclaim. I want to highlight that as well, because for this one, I think, because he says a reference to Shannon's attitude to fame. So Shannon developed information theory but shunned the resulting acclaim. The shunned resulting acclaim means he denied, he refused to accept the public praise. So yeah, that's pretty much that is going to be the answer for us, and I'm gonna underline that as well. So we are necessarily, we are right on track. So 29 is going to be B here. So I'm just gonna remove this and choose red color. So I'm just choose there as well. C. Now we have C. This all seems light years away from the cut down to earth uses Shannon's originally had for his work, which began when he was a 22-year-old graduate engineering student at the prestigious Massachusetts Institute of Technology (MIT) in 1939. He set out with an apparently simple aim: to pin down the precise meaning of the concept of information. The most basic form of information, Shannon argued, is whether something is true or false, which can be captured in a binary unit or bit of the form 1 or 0. Having identified this fundamental unit, Shannon set about defining otherwise vague ideas about information and how to transmit it from place to place. In the process, he discovered something surprising. It is always possible to guarantee information we'll get. So it is always possible to guarantee information we'll get through random interference, noise intact. Okay, so it's a really do we have anything here? So let's see. A reference of the Shannon initially intended to achieve in his research. Maybe, no. A reference to what Shannon initially intended. He set out with an apparently simple aim to pin down the precise meaning of concept of information, the most basic something, blah 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 blah. Set out with means it's another way of saying initially. So a reference to Shannon's initial intended to achieve in his research. So I think that's paragraph C here. I'm just going to underline that. I'm just going to take advantage of highlighting C. So we don't have, pay attention, we don't have an NB here usually, meaning you can use any letter more than once. So there we go. Now going back to D. Noise usually means unwanted sounds which interfere with genuine information. Information theory generalizes this idea via theorems that capture the effect of noise with mathematical precision. In particular, Shannon showed that noise sets a limit on the rate at which information can pass along communication channels while remaining error-free. This rate depends on the relative strengths of the signal and noise traveling down the communication channel and its capacity, its bandwidth. The resulting limit given in units of bits per second is the absolute maximum rate of error-free communication given signal strength and noise level. The trick Shannon showed is to find ways of packaging up coding information to cope, meaning to deal with the ravages of noise. Really nice one. So the ravages of noise means to the destruction. So like some damages of noise. So the ravages are like it's like I think destruction caused by something. So ravages of noise means another way of saying damaged noises. So while staying with the information carrying capacity bandwidth of the communication system being used. This is another pretty nice paragraph they're demonstrating here. And so what do I think here? An explanation of the factors affecting transmission of information. So this is a really nice word here. An explanation of the factors affecting because noise usually means unwanted sounds which interfere with general information. There we go. We have something like that. Information theory generalizes this idea via theorems that capture the effects of noise with mathematical precision. In particular, Shannon showed that noise sets a limit on the rate at which information can pass along. Pass along is another way of saying transmission. Pass along communication channels while remaining error-free. So pass along communication channels. So I think that's 27 is going to be paragraph B. All right, 20. We are left with two more here. Over the years, scientists have devised, meaning invented, many such coding methods, and they have proved crucial in many technological feats. All right, so feats is an action where technological feats. A feat is a piece of work that requires a lot of skills. So of course, coding is like coding is really coding is really hard to a certain point, because you have to learn a lot of programming languages, because at the same time it's not like English language, because coding can be many programmers invent frameworks and different kinds of technologies every day. So the Voyager spacecraft transmitted data using codes which it added one extra bit for every single bit of information. The result was an error rate of just 1 bit in 10,000 and stunningly clear pictures of the planet. Other codes have become part of everyday life, such as the Universal Product Code or barcode, which uses a simple error detection system that ensures supermarket checkout lasers can read the price even on, say, a crumpled bag of crisps. Crumple means crushed. I mean, crushed bag of crisps, crushed into several folds. As recently as 1993, engineers made a major breakthrough by discovering so-called turbocodes. So I want to highlight this. I just kind of love this expression, which comes very close to Shannon's ultimate limit for the maximum rate that data can be transmitted reliably, and now play a key role in the mobile video phone revolution. An example of how unnecessary information can be emitted. Is that what we're searching for, or not? Or details of machine capable of interpreting incomplete information. Okay. That's what I think. Other codes have become part of everyday life, such as Universal UPC or barcode, which uses a simple error detection system that ensures supermarket checkout lasers can read the price, even say on a crumpled bag of crisps. Okay. That's a really good one, because let's see, details of a machine capable of interpreting incomplete information. The Voyager spacecraft transmitted data using codes which added one extra bit for every single bit of information. The result was an error rate of just 10,000 stunningly clear pictures. Engineers made a major breakthrough, which details of a machine capable of interpreting incomplete information. Over the years, scientists have devised many such coding methods, and they have proved crucial in many technological fields. There's a really nice one here. Details, but I'm pretty sure that it's talking about machines devise many such coding methods, and they have proved crucial in many technological feats. Let me just take that as an E, because I'm not quite sure, but incomplete information is like incomplete other codes, which uses a simple error detection system that ensures supermarket checkout lasers can read the price given on, say, a crumpled bag of crisps. So details of machine capable of interpreting incomplete information. Capable of interpreting incomplete information, which added one extra bit of every single bit of information. The result was an error rate of just 1 bit in 10,000. Okay, so there we go. The word which added one extra bit for every single bit of information. So added one extra for every single bit of information. The result was an error rate of just one bit in 10,000, and suddenly clear pictures of the planets. So meaning that what they're saying here is that they use some sort of a code, some sort of computer code. They had added one extra bit for every single bit of information. That means, for example, a crumpled bag of not a crumpled bag, but they added one extra bit for every bit of information. A bit of information can be crisps, and the result was an error rate of just 1 bit in 10,000. Stunningly clear pictures of the planets. Other codes have become part of everyday life, such as universal product code or barcode, which uses a simple error detection system that ensures supermarket checkout leaders can read the price even on, say, a crumpled bag of crisps. Alright, so Shannon's ultimate limit for the maximum rate the data can be transmitted reliably. Ultimate limit for the maximum rate. So yeah, that's ultimate limit for the maximum rate as another way of saying incomplete information. So I just want to take that's exactly what we want to see. Shannon also laid the foundations of more efficient ways of storing information by stripping out superfluous, meaning redundant bits from data which contributed little real information. As mobile phone texted message like I see and see you show, it is often possible to leave out a lot of data without losing much meaning. As with error correction, however, there's a limit beyond which messages become too ambiguous. Shannon showed how to calculate this limit, opening the way to the design of compression methods that cram maximum information into the minimum space. Superfluous, redundant. Okay, we have really another some sort of challenging. Although I don't really find it necessarily challenging here, but we still have to kind of know. What are they referring here? Laid foundations of more efficient ways of storing information by stripping out superfluous bits from the data which contribute literally real information. So they just removed. Stripping out means removing unnecessary information, unnecessary bits of information, which didn't even had any real information. So an example of how unnecessary information can be omitted. That's what I think, as far as I can say that maybe 28 is probably, because omitted is like stripping out. So yeah, like let's just choose F. Was an F? Yes, let's just F. I probably think that's an F, because we're not left with any other paragraphs. We're not left with any other paragraphs. So the last paragraph is F. Now, if we go for the sentence completion, so the probe transmitted pictures of both something and something, then left the something else. Okay. Let's just search from the paragraph A. So we know the space probe. So the space probe Voyager 1, launched in 1977, had sent back spectacular images of Jupiter and Saturn. So I think that is a Jupiter and Saturn here. Jupiter. So let me just take that, and Jupiter and Saturn. Then left so pictures of both. Send back spectacular images of both, and then stored out out of the solar system in one-way mission to the stars. Then left the solar system. So stored out of the means to living out of the solar system. This becomes a little bit easier than we thought. So solar systems. The freezing temperatures were found to have a negative effect on the parts of the scope. The freezing temperatures, so we have the freezing temperatures over here. I just want to highlight that now in cyan color. Scientists feared that both the something and something were about to stop working. NASA experts realized that they had to do something or lose contact with their probe forever. The probe was beginning to show something else. What the solution. Okay, sensors and circuits were on the brink of failing. They were like stop working, brink of failing. Sensors and circuits. Scientists fear that both the sensors and circuits. There we go. Let me just choose a better one. Sensors and circuits were about to stop working. So like sensors and circuits were on the brink of failing, and NASA experts realized that they had to do something or lose contact with their probe forever. Yeah, sensors and circuits. All right, there we go. We're about to stop working. The only hope was to tell the probe to replace them with something, but distance made communication with the probe difficult. The solution was to get a message to Voyager 1 to instruct it to use spares to change the failing parts. To what? To use the spares? Replace them with spares? Yeah, probably. The only hope is to tell the probe to tell the probe means to instruct it to use spares to change the failing parts. Use spares, but distance made communication with the probe difficult. So they're saying the problem 12 billion kilometers was not an easy task. So it was difficult because of the destination. A something was used to transmit the message at the speed of light by means of a radio dish belonging to NASA. Blah 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 blah. The message was sent out into the depths of space. So a radio dish. There we go. A radio dish was used to transmit the message at the speed of light. So a radio dish belonging to NASA's Deep Space Network. The message was sent out into the depths of space, even traveling at the speed of light. So yeah, we have 37. We have as radio dish. We're gonna take that. So we are allowed to use no more than 2 words. I just want to highlight that as well. Okay, the message was picked up by the probe. We don't really necessarily need that. Now, true, false, not given. The concept of describing something is true or false was the starting point for Shannon in his attempts to send messages over distances. The amount of information that can be sent in a given time period is determined with the reference to the concept of describing something as true or false. There we go. True or false. Let me just choose a maybe some sort of purple, I guess. The concept of describing something as true or false was the starting point for Shannon in his attempts. So initial attempts, some sort of initial attempts. So what happened to him? Shannon. Okay, we have that. True or false, which can be captured. Shannon said about defining otherwise vague ideas about information, how to transmit from place to place. Shannon showed that noise sets a limit on the rate at which information can pass along channels while remaining error-free. And this rate depends on the relative strength of the signal and noise traveling down the communication channel and its capacity is bandwidth. The resulting limit given its bit per cent absolute trick of error-free communication given signal. The concept of describing something as true or false was the starting point for Shannon in his attempts to send messages over distances. Shannon showed that noise sets a limit on the rate at which information can pass along communication channels while remaining error-free. This rate depends on the relative strengths of the signal and noise traveling down the communication channel and on its capacity and its bandwidth. That's a really good one. To send messages over distances. The concept of describing something as true or false was the starting point. or is that what we're looking for, or not? But not really. But how I feel, the most basic form of information, Shannon argued that it's whether something is true or false, which can be captured in the binary unit. Because he set out with, of course, as I told you before, is like starting point. So he set out an apparently simple aim to pin down the precise meaning of the concept of information. The concept of describing something as true or false was the starting point for Shannon in his attempt. So he set out with an apparently simple aim to pin down the precise meaning of the concept of information. The most basic form of information, Shannon argued, is whether something is true or false, which can be captured in the binary unit or bit of the normal of the form of 1 or 0, meaning 0. Having identified this fundamental unit, Shannon set about defining otherwise vague ideas about information, how to transmit it from place to place. This process, he discovered something surprising. It is always possible to get information will get through random interference, noise intact, so like over distances. I think that's true here. Let me just write that normally. Because he says that he set out with an apparently simple aim to pin down the precise meaning of the concept of information, the most basic form of information. Shannon argued is whether something is true or false, which can be captured in the binary unit. Starting point is that he set out with. So yeah, that's true. That's why. However, the information, the amount of information, and the amount of information that can be sent in a given time period is determined with reference to the signal strength and noise level. That's another true, because we found here Shannon showed that the noise sets a limit and rate which can which information can pass along communication signals while remaining error-free. This rate depends on the relative strength of the signal. So the amount of information that can be sent in a given time period is determined with reference to the signal strength and noise level, and noise traveling down the communication. So that's another true for us. So we're gonna take true. All right. Products have now been developed in which can convey more information than Shannon had anticipated as possible. And I know that products have now been developed. Products have now been developed. Products have now been developed which convey more information than Shannon had anticipated as possible. So, devised, meaning over the years, scientists have devised many such coding methods. And as recently as 1993, sorry for that, engineers made a major breakthrough by discovering so-called turbo codes, which come very close to Shannon's ultimate limit for the maximum rate that data can be transmitted reliably, and now play a key role in the mobile video phone revolution. So the products are turbo codes, by discovering so-called turbo codes. So now we're just going to convey more information. Convey more information. Do they convey more information? Which can come very close to Shannon's limit. They come very close. They come very close to Shannon's ultimate limit for the maximum rate. Very close to the maximum, so very close to the Shannon's ultimate limit for the maximum rate. But however, this one is saying convey more information than Shannon had anticipated as possible. So it does not exceed the limit that Shannon suggested for the rate of reliable transmission. The result was an error-free just 10,000. So they invented a product called TurboCode, which comes very close to Shannon's ultimate rate for the maximum rate that data can be transmitted reliably, and now play a key role in the mobile video phone revolution. The rate of reliable information data, they almost reach this limit. They come very close to the ultimate limit for the maximum rate. So the answer is false. So as you can see, guys, we necessarily didn't find a not given. So there we go. This is the first thing we have to know, that true, false, not given, or yes or no given, they don't always, meaning you will not you will have some situations. I mean, you will face or witness some sort of times or I'm sorry for the not circumstances, but times when one of the options are not going to be used. So yeah, there you go, guys. We've finished test number 3. This is the concluding passage, reading passage 3 for test number 3, Cambridge 9. If you have any questions, please feel free. I'll be very happy to respond back to your question. You can leave your questions in the comments section below, and once again, I'll be very happy if you leave any question that is something that is not clear for you. So yeah, if you found this video helpful, please hit that like button and subscribe if you haven't still. I thank you very much for watching, and yeah, so of course, if you really found it helpful, and you might share with your friends or family members, so we can pretty much extend or just improve this channel. Your support means a lot for this channel to keep functioning, so we can upload such content for free, absolutely free of charge, for everyone so who are seeking to land a pretty decent score in IELTS examination. So there you go, guys. Thank you very much for watching. Once again, please subscribe if you haven't. Thank you very much once again. Very much too for watching. Just hit that like button. Yeah, have a wonderful time.